একটুখানি রেখে দেবো ক্লাসটা নিয়ে, ঠিক আছে? তুমি একটু বসে দিয়ে ক্লাসটা আমার এখানে 12টার মধ্যে শেষ করো। 12টায় শেষ হয়ে যাবে। Good morning. Hello.
Good morning,
Good
ma'am.
morning.
Good morning, ma'am.
Good morning,
Good
ma'am.
morning, ma'am.
Good morning, ma'am.
Good morning, ma'am.
Good morning, ma'am.
Okay. So I will start just from little bit back next previous class note for the chemical shift. So we already know about the NMR. So what is NMR in one few words? Say something. What is NMR? Hmm? Full form of NMR? Hello, say something.
Nuclear magnetic resonance.
Okay. Then what is the what type of actually element we are the basic need for the NMR?
Deuterium.
No, not deuterium, proton. So unpaired electrons should be there. So H1, then 13C, then fluorine, phosphorus 31, phosphorus, fluorine 19. This type of element actually can perform for the NMR analysis. So for them, for the analysis of NMR, we need some actually terminology. So one of them is chemical shift. So chemical shift, for I am explaining here with respect to proton in detail. So for chemical, understand the chemical shift, first we clear about one internal standard for NMR analysis. We can use internal standard. So what is this name? TMS, tetramethylsilane. And the structure is here, silicon, and there is a 4-methyl group. Now this 4-methyl group I mentioned here, highly shielded. Last class I mentioned about the shielded and deshielded. So what is this means, shielded? Shielded? Sealed. The electrons are sealed. That what is the meaning actually? Say something. You have to capture this thing, chemical sheet. Otherwise, this is actually your part for semester exam. So what is shielded means?
Ma'am, shielding effect এর মতো।
Huh?
Ma'am, shielding effect সেই ম্যাডাম atomic structure।
Yeah, so what is the meaning of highly shielded here? So that means actually the electrons, this silicon and carbon between and the proton are not moved actually. They are like stagnant with the proton. ঠিক আছে? They are not, there is no extra pulling effect or pushing effect. The proton with their one electron is stagnant. And when we apply the magnet field, because of the shielded electron actually, it immediately resonates. Okay, but if the shielding effect is less, little bit, so it takes later on slowly with the resonance with the applied magnetic field. So what is this resonance means? Applied magnetic field have one frequency, and the electron they are orbiting have some frequency. When they are actually matched, they are resonant. So promptly, because of these 12 hydrogen are well shielded, they vibrate and they resonate with the first application of applied magnetic field. and that is actually the TMS signal. So this is proton appears, the upfield, and actually the scaling started from here. So TMS, where the resonate actually, it is internal standard, and we mark this place as 0. And then we go to the left hand side and the towards the lower field, downfield. Downfield means the magnetic applied magnetic is consumed through the
কিন্তু হয়ে গেছে
হ্যাঁ
কিন্তু কি পাঠাতে হবে
কিছু বলছো
যাই যাবে ঠিক আছে switch off your mic Suman
So after downfield, so that means you have actually the magnetic field are consumed by each proton which are slowly descending with respect to TMS and resonance. So it's consumed. So that is downfield. Upfield, start from the TMS and then going downfield. Now, actually I mentioned yesterday in previous class too, but I repeat because this is very basic thing you actually go through very clearly. Concept should be clear. Now, with respect to actually this TMS, we can make a scale for NMR presentation. Okay. The standard reference substance used universally is TMS. For all over in the world, we use the TMS as internal standard. And internal standard has some requirements. What is this requirement? I mentioned last class. Tell me, or at least two. What is the requirement for use as internal standard? What is the requirement? It should not be react with any material which we are going for analysis. And another point, it should be soluble in solvent, because for NMR we use NMR inactive solvent. That is, all solvent should have deuterium, not the proton. H, only D. So it's not merged with any sample C. That is, and also sometimes you can say it's not thermal stability will be there, all are there. So chemical shift thereafter in ppm, and you can down actually write down the designation as designed as delta. So delta is equal to shift from TMS in hertz divided by spectrophotometer frequency m hertz into 10 to the power 6. For CH3Br proton, chemical shift from TMS is equal to 162 Hz in a 60 MHz instrument and 270 Hz in a 100 MHz instrument. Calculate delta value. This type of question will come. What is the delta value of one? We will supply one molecule and you have to tell. We provide all the data. Now delta is equal to, for the first from the 60 megahertz instrument, 60 megahertz means depending on the applied magnetic field. So if the magnetic field is higher, that means the instrument is better actually for performance, for detection, for sharpness of the appearance of peak, because if the power is higher, so that it can long time can resonate and at the proton with a perfection for defeated in manner very clearly. So delta is equal to 162 by 60 equal to 270 by 700 equal to 2.7 ppm. So whatever the machine intensity actually frequency 60 or 100, now that is not in any calculation, not in any. The delta value is fixed for the this CH3 proton 2.7. It's not depends on the instrumental frequency value. That's why we divided by this one. Okay, so it's ppm. Hence delta value remains same irrespective of the spectrometer. Now deshielded by this thing now, I also repeat this again. So here is a Cl, C and H. Actually, this proton only have prompt response for the NMR. For C is a 12, mostly 12, and the abundance of C13 is 0.09 or 0.01%, but proton abundance is 99. So depending in a molecule, so proton abundance is 99%. So it gives response quickly. If you want to calculate, want to know the 13C value, then you need to run more time because the abundance of proton, the carbon 13C is 0.1%. So it needs a long time to accumulate its resonance frequency, and then we can multiply actually, amplify its frequency to in a record. Okay, so it's time consuming for 13C NMR, but proton within a second you can get result because this availability is in molecule is large. Okay, but you need the solvent should be present, the deuterated solvent. Suppose for this type of molecule you need chloroform, but not chloroform CHClC. You need CdClC. Okay, so the proton from the chloroform not affect the NMR spectra of this type of any molecule. So chlorine deseals means chlorine have minus I effect and it withdraw electrons. You can see by dark blue color. Okay. So now electrons are going towards the carbon and towards the chlorine. So the concentrations or electron cloud is less in the proton. So its frequency is now lower. And what happens? The applied magnetic field slowly consumed towards the down field. Whenever its frequency and this proton frequency are matched, it resonates and we get the signal. Okay, so depending on the chemical environment, actually, their structural environment, which the proton, all protons give different type of signal. Both are all are protons, but their chemical environment is different. So they give different signal due to different type of deshielding effect. That is deshielding effect. So deshielded proton appears at low field and highly shielded proton appear at the high field. And I already saw this chart also that there is a, I fixed the CH3 group and I changed one fluorine, OE, Cl, Br, I, CH4 and this is CMS. CMS is zero chemical shift, but you can see depending on the electronegativity or deshielding or withdrawing effect, the delta value is changed. So fluorine is the most electron withdrawing, so the value is 4.24 and for CH4 is 0.23. So replace one proton by fluorine gives a large shifting of proton towards the downfield. So that is actually the beauty actually for NMR. The signal can be identified and you can understand the chemical structure, surrounding chemical structure, backbone of a particular protein. Okay. And it is so repetitive. So same type of compound gives the same type of proton in signal actually all the time. So that is not the depending on different compound gives a different product, different spectra. That is not done. Whatever, if there is the impurity, they will give the separate peak. The original peak will be always there. Okay. Now, another one, most distillate, suppose we are taking here CHClC, one CH2Cl2 and CH3Cl. So, one chlorine, one monochloro, dichloro, trichloro. Now, depending on this proton, we have to actually see what is the chemical C. For the monochloro, the value is 3.05. And when the chloroform, so it's 7.27. That means the deshielding effect is maximum for the from 3 chlorine atom with respect to 1 chlorine atom. Okay, the effect increases with the greater number of electronegative atoms. Most dishielded, again, we just increase the chain length now. CH2 CBr, CH2 CH2Br, and CH2 CH2 CH2Br. Then what happens is bromine is far apart from the proton. We want to get the peak. Okay, so it's 2.5. If it's so close, then its direct dishielding effect by its minus I effect directly reflects in the delta value, and it dishielded also happens, and you will get a 3.30 delta value. Okay, so the effect decreases with increasing distance. That is same as the minus I effect. So minus I effect. So same. So delta value increase because of the decrease of the minus I effect of the this type of group or element present in the molecule. So this is from chemical shift. Now we will go for another very important parameter, how we differentiate proton, methyl proton, methylene proton, or CH. There is a three type of proton, na? Aromatic proton, CH proton, CH2 proton, CH3 proton, and aromatic proton. So how to differentiate this, and how the neighboring proton can predict the nature of proton. Either it is methyl or methylene. For this one, we have new things naturally thought, that is spin splitting. So there is a spin, no? Proton all are one spin, suppose. So they are how to behave with each other. Depending on this, the signal will be split. That is spin split means signal will split for a particular proton. That we will see, and there is very nicely you can see the beauty, that very rhythmic pattern we can get, and there is a thumb rule, n+1 rule. Now spin splitting, often a group of hydrogen will appear as a multiplet rather than as a single peak. Okay, depending on the methyl, ethylene, etc. Multiplets are named as follows. If there is a one signal, we tell singlet. If two, doublet, triplet, quartet, quintet, septet, octet, nonet, etc. This type of we will go, and this happens because of the interactions with neighboring hydrogens and is neighboring hydrogen. So role of neighboring hydrogen is very important to understand the spin splitting. This is we can find as n+1 rule, thumb rule for NMR splitting. Now, some calculation. This hydrogen is split by its two neighbors. So this hydrogen, and it has two neighbors, two protons, neighboring protons. Two neighbors and n+1. So n is the neighboring proton. This small n, that is n plus rule, this n represents the number of neighboring protons. So how many actually splitting patterns? 2 proton, 2 plus 1 is equal to 3. So this proton gives multiplet triplet. It appears as a triplet peak. Clear? And next one, so this proton, there is a 2 proton. These 2 protons each have one neighboring proton. Only one neighboring proton. Both have. So n+1, so 1 is equal to 1 proton equal to 2. So these 2 protons appear as doublet. Okay. Now, suppose this one. So Br bromoethane, I just took general, and here is the NMR. You can see this is the signal for the TMS 0, and then we will get these two set of signals. But we have only two types of protons, CH3 proton and CH2 proton. CH2 proton, methylene proton, how many neighboring protons?
3.
3. So n+1 rule, execute n+1, n is equal to 3. So it has
4 peaks.
4 peaks. So quartet. So obviously CH2 appears as quartet form. So this is quartet. You can see. So this is CH2. And for CH3, how many neighboring protons? For each CH
2.
2. So
2.
is n plus 1 according to 3. So triplet, you will see this one nicely. So this is methyl peak for bromoethane and this is methylene for bromoethane. Clear from here? What is mean of multiplex? Now
Yes,
we
ma'am.
see the intensity. What is the pattern of intensity? This part is very important for you. That is very qualitative. By observing the molecule, you can say this one, even their value. What is the delta value for methylene proton? You can see between 3 to 4. Okay, because these are in a higher delta value or downfield because Br is directly attached to methylene proton. Okay, and pH is little bit distance. There is a distance. So same thing reflects the chemical C. So between like 1.5 is for methylene and 3.5 for methyl, and this one is 3.5 for methylene. Clear? Chemical shift and the splitting. Tell me, because the question will be like that. You have to understand the position of chemical shift and you have to understand the splitting pattern. You have to describe this thing. Very simple, but without money, feel it, you can write down. You don't need to even memorize all the time, but now you have to think. Very simple, like mathematics. If you learn, you learn. Clear from right? The chemical shift and etc.
Yes,
Yes, ma'am.
Okay, so now go to the next one. Now tell me, one is this hydrogen and there is a 2-methyl and here is a nitrogen. Now first we will tell H. H and how many neighboring proton for this H? Only this one. How many neighboring?
6.
6. So what is the according to thumb rule? What is the multiplicity?
Septet.
7. So obviously the value is there. Okay, and also you can see this nitrogen is directly attached to this hydrogen. So it's more defilled and it appears at the downstream. So this one's the positions and the multiplicity both confirm that the proton actually showing the signal here. Only single proton, but you see there is a multiplex because of the neighboring proton. And this proton, this methyl group, how many neighboring protons?
4.
No. These methyl
1 1.
identical. They are
Oh, 1.
split, cut it half. So methyl are in equal. Okay. So that's why both the methyl have proton H, 1. So 2 doublet, you will see the doublet. But you see this intensity is far lower and the intensity of this peak is higher because of it involved 6 protons and here involved only 1 proton. You can integrate this value. Actually NMR spectra also integrate the value and you can get a value equivalent to 1 proton, equivalent to 6 proton. All data you can get from NMR. Very simple thing actually till now. So all clear why this peak is so high and this peak is so low intensity?
Yes, ma'am.
And because this peak actually represents 6 protons and this peak only represents only 1. So accordingly the peak length or intensity will be different because of the presence of number of protons. Okay, high and low. So then next, now this one. So this is actually Pascal's triangle, something you know about that. Now Pascal's triangle. So if you count down it forms some figure. You will get some figure. graphical device used to predict the ratio of the height of the lines in a split NMR peaks. Height of the line. Suppose you have this one, this value actually. If you have this one, suppose what is the length of the each line, you can predict from the Pascal's triangle. This is the calculation for singlet. Okay, what is Pascal's triangle? We just draw this value 1, then you come 1 and 1. So 1, first you shift the 1, okay, and then you make a sum 1 plus 1. This is 2, then 1 coming down. Then again 1 coming down, 1 plus 2 is equal to 3, 2 plus 1 is equal to 3, and 1 coming down. Again 1 coming down, then 1 plus 3 is equal to 4, 3 plus 3 is equal to 6, and 3 plus 1 is equal to 4, and 1 coming down. Actually, this is the ratio of the line formed in the multiply. So for singlet is 1, doublet is 1:1, okay, or you can, here is something writing. There is a mention about the number of peaks, okay, number of peaks actually, okay, and their appearance. So whatever, we are not concentrate this one. First the line, this one. What is the ratio of the peak intensity for each line splitting? For the singlet 1, for the doublet we will get a 1:1. For the triplet we will get 1:2:1. For quartet we will get 1:3:3:1. Now with the given example. Okay, how it? So this proton is only 2 neighboring protons. So 3 is a triplet. So how it looks like? This one is the triplet. So 1 to 2 is to 1. That is the line intensity. And whole represents only 1 proton. And here again we just take CH2. So there is a 4, because it's symmetrical actually. So 4 protons. So 4 protons means 4 plus 1. So quintet. So that means 1:4:6:4:1. That is the pattern of the line, the peak intensity of the each line, because of the splitting of the due to the presence of 4 neighboring protons. Of this proton you will get this pattern. Okay, clear? So this, you have to tell this thing. We provide the molecule, you have to tell the probable chemical shape position, you have to tell the spin splitting nature and the line intensity according to the Pascal's triangle. This type of question, very simple question, but if you don't know the exactly what happens with this thing, you can write it. And it's not so much loaded also. If you learn at one time, it's forever. Okay, it's not like memorize all the time by reading. So this is some concept. So if you know the concept and understand the concept, break the concept, so you will be gainer. Clear?
Yes, ma'am.
Yes, ma'am.
It's very simple. I will send this actually for this one preparation, and this the initial part you can go through. I have initial part the NMR, but you go through for any basic book. But this part you need, and I clearly describe everything, so you just understand and make it your for questionnaire preparation. Now I am taking some example for, suppose this one. They are isomeric, no? These two moiety isomeric.
Yes, ma'am.
Okay. Next day we'll go little bit more about NMR and stuff polymer, but now just 2 or 3 examples. So here I point out all the peaks actually. So I point out for this aromatic proton all have 7. Actually, this is there is some chart, and I already mentioned the proton peak appear for a particular chemical environment is very much fixed. Like FTIR, the frequency for hydroxyl group is 3000 centimeter inverse, is fixed. So there is a range actually brought here. So here also the aromatic range, aliphatic range, methyl group, when it will appear, the chart is fixed. Okay. The value, delta value is almost fixed, little bit difference because of the neighboring environment. So now here is a methyl group 1.25, here is a methylene 2.6, and also you can see this one. So for methyl CH3 neighboring group is CH2 2 proton, so 2 plus 1 3. Okay, so you see this one is splitting as 3, this one is splitting as quartet, triplet quartet. Now these aromatics are something, you see these two are same, these two are same, and this is one. And this, it has two actually proton in neighbor. So 3, but as a whole is little bit complex because this has again 2, this has again 2, but their range is almost nearly merged with each other. So its appears are in like a multiplex, but the range predicts that it has aromatic group. So it's okay. Now what is its isomeric? Here see the difference for Na1. We have no peak at this region, methyl region. Okay, only we'll get 2.34. And again all aromatic peak are gives at one position because a symmetrical moiety. Okay, so now from there we by picture we can understand this is some symmetrical molecule for aromatic region 1. So we put these two group are there. Both are methyl. It's shifted because of this identical formation. Okay. And here also you see this is singlet because there is no neighboring proton here. So it gives singlet. And these are all identical, that's why it appears also as a singlet. Clear? So NMR spectra is very simple to understand and characterize a particular molecule very nicely and is a non-destructive. Okay, you just solution in a deuterated solvent, place it, and you can recover it. No, you have no problem for this the destruction of the sample. You can keep it. You can use for another purpose. Now this one, it is also some isomer. This type of molecule will come, for example, differentiate the. They are both are isomeric. Differentiate by NMR spectroscopy. You have to draw the structure, tell the probable positions actually, the chemical shift position, their splitting pattern, etc. in detail. So we can sometimes we for the compare you just make one position also, or you can describe all depending on the number you can understand. So here this is a one methyl group and rest is the other part. Keto. And here is a, you can see this is also identical. So there is a 1.06, 2.47 methyl and methylene with respect to ketone. So now methyl 1, so 2, that means methyl has triplet, you see the triplet, and this is nicely quadruplet. Fine for this sample, but it is not a identical, symmetrical. So one methyl and rest are different. Okay. So here, how to identify 1.68? These CH2 actually have two proton, this from neighboring side and 3. So 2 plus 3, 5 plus 6. 5 plus 1, 6. So this is 6 step. This is this one. 1.68. For 0.31, And why this difference 2.13 and 0.90? Both are methyl group, but this methyl group are desilted because of the direct presence, direct attachment of the keto group. Electron withdrawing effect, desilted, so it's shifted. And it has no neighboring proton. And you see the value only the single. And here there is a 2 neighboring protons, so 3 you can get a triplet. So it's clearly understandable the nature and peaks is clear almost all the time if you have no impurity. Sometimes some impurity will come, but the nature of the peak can tell you the compound is there. So that's why NMR is neat and clean and non-destructible spectroscopy is clearly understand for the characterization of NMR samples. Clear? This part you have to break actually. This concept you have to think and you have to yourself, make it yourself. So that during exam time, by one night it's not possible to understand. By calculating or exercising with different type of molecules, you can attain. So up to this, for 2 examples, from these questions from this type of question will come from previous year. So this example I included here, and I will go for also some example here. So next we will go for another set of examples. Okay, I will send this whole data, this course material. Okay, you just go through, but basic part about this spinning, etc. The Spavia book is okay, or any other basic spectroscopy, proton NMR spectroscopy you can go through. But this part only, this whole whatever in these slides are related to the making some actually thing for the final your question paper. Okay, I will next day will you will tell, I will give some molecules, you will tell their splitting chemical shift position. Okay. And initially I will describe some this area, what type of area like proton NMR, aromatic proton is 7,2, then aldehyde proton where it will come. This I will tell, and then you will give some molecules. You will tell me about the their chemical shift and the tentatively spin multiplicity and the n+1 rule actually. There is one question always comes, what is the role of Pascal's triangle in NMR spectroscopy? I already mentioned the peak intensity of the during the spin multiplicity. You draw the multi, you don't need to write so many things. You draw the spin splitting parameters like this way. Okay, I have this slide is okay for this type of question. Not for this value, this is something, but you can, this slide up this figure are sufficient for this question. What is the role of Pascal's triangle in NMR? And you can include here what is spin multiplicity actually first. Then you just write down or whatever from here. I write down everything, so just few words you can add. Here.
Yes, ma'am.
Yes, ma'am.
So for today, up to this, I will send this for you, and next class continue this NMR little bit. Okay, it's a very new concept, but it's very much important because you see the advantage for the making the molecular characterization so neat and clean, and it's just few seconds you can understand. Only you need one NMR machine. Okay, and NMR proton NMR you don't need so much price actually for charges. Actually, it's 50 rupees to 100 rupees per run, per analysis. So it's cheap. So that's why this is very important actually spectroscopy. Whatever you learn about the FTIR and etc. From here, you get all the data very nicely with the environment also, fully characterized you can done by AI. And if you have mass of the total, that's nice. You just feed both. You categorize and your mass is there total. You just combine it, you will get the total data for a particular molecule. Hmm. So
Excuse me, ma'am.
hmm,
Ma'am, our Viva exam would be online or offline?
I think it's offline. After
Ma'am, is there, ma'am, like when everything is opening on 21st only?
I think for you still not decided, they will actually give you after the hostels are under construction. Some there is some work is pending, and few students are there because of maintaining the COVID protocol. Actually, the students from the higher semester are split in the different hostels. Now the COVID protocol is almost gone, so they first higher semester leave their this room, then you can accommodate. They actually all the
Ma'am,
rooms
ma'am,
under
will the
top
end sem,
secret.
ma'am, actually the end sem is 10 days after that, ma'am, so
I think
will,
everything will be strict.
okay, ma'am, ma'am,
Strict
because it
on
will be
that.
very difficult to like go to hostel, adjust and give
And
end sem
only
10
for
days
exam
after.
you will come. Whatever your syllabus, because I think if you not going for the offline exam, maybe later on the UGC tell me no, we are not we already give the notification. So now the online, if you go, suppose we will go for the online, then they will tell now we evaluate again with the offline. Then it was a mess. It will be mess actually. Understand? So whatever
Yes, ma'am.
will give you whole support, so not a problem. Viva is just for
So will the end sem be postponed or like any syllabus
I
reduction will be
think
there? Because it will be
he
very difficult for us.
is here now. He is in Delhi, so he will come and decide. And we have actually very quickly 11th for 11, from 11th we have convocation. So that's why the decision will take some time, and
Okay,
hopefully,
okay.
okay. So after actually the students still higher semester students still not evacuate the your first semester hostel, because that time you are not here, and they provide the hostels for higher semester for COVID protocol. They need two at room, so that's why this happened. Now after their shifting to the another hostel, their lock and key have room will be free, and then they actually some cleaning etc, and you will then they will register for you actually. Okay, so this will going on for higher semestering going on. So they are shifting, if late, then your actually entry will be late. But whatever your
But
exam,
ma'am, in offline exam, the pattern of questions will be different and the marks will increase. But we practiced in this pattern.
or the final sem is 50 marks. It's not offline is also 50 marks.
Means the pattern will be same as it was like earlier in online sem.
Little bit. Is actually time is same.
As previously it was 3 hours when actual offline exam used to
For
go on.
50 marks, I think it's not 3 hours. For 50 marks, it's 3 hours. No, there
No, no,
was
No,
previously it
ma'am.
was 100 marks, I think.
100
No,
marks,
that was 70 marks, I think.
70 marks.
Yes, yes.
Now your system was actually different from since last 2 years, I think. 50 marks for 1.5 hour, na?
Yes, ma'am.
Mhm.
I mean, it
So
was for online, so if
it
on
depends.
offline semester happens, then that thing will be continued or changed.
For time and everything will be same. Actually, you can. This is according to ordinance. You can see
Hello,
the.
ma'am. Can I ask something?
Hmm,
Yeah, it's ma'am about the lab notes, ma'am.
hmm,
Actually, I'm making the notes
hmm,
like making a table,
hmm.
experiment, observation, and result. Is it okay?
Is okay. Whatever. So it's just assignment, but Viva will go for online, offline.
Okay, ma'am.
Actually, you will come here also. We will demonstrate, visit the lab, but you have not so much accommodate. Or maybe you have like 15 days to visit our institute, and you have lots of practical for us for different department. You have practical. So we
And ma'am, is there any gap of week for re-accommodate ourselves from home to the hostel? Will
I
there be
don't
any
think when
off
after
class?
your class is class may be 50 to 28, I think so. I don't know exactly because up to 28, then you will come. So for from there, that time actually you will be going preparation for exam offline, and we will show you some demonstrations if you want in chemistry and take the vibe. And
And
then
ma'am,
discuss.
in the final
Hmm?
exam in offline, will we be asked to perform the tests?
Oh no, that actually is not possible maybe because you have only one day maybe for each day, one day for chemistry. So how will manage this one? By showing the demonstrations and everything. So we demonstrate you and talking about the Viva, and next day we will going for the Viva. That we are thinking actually, because how to manage all so many experiment in one day. Okay, and one experiment is also difficult. We set up some exam. We are thinking, planning actually to show you something by some few practical for regarding the organic chemistry. So these are very easy to show by testing mainly. So, so first, actually, whole committee will decide, then we will. But your exam, everything in offline. Otherwise, you
Okay,
will
ma'am.
be in trouble. You have to again, maybe according to UGC rule, you
But
have
I
to
mean, in middle of semester,
off.
suddenly offline exam, I mean, it will be difficult for us. Like, we have to accommodate new
So
system.
see, this year about the class 12, they are going for how? They are going for two term, first term, second term examination. How they accommodate? All are offline. They are performing. If they are performing, why even not?
So, no, I'm actually we have to go new place. Like, we have
Huh?
to accommodate in new environment in such
Suppose
place.
Ma'am,
no,
ma'am,
these are your college, you will accommodate. I know. Within you are so much touched. Actually, you are all in a group. You are when your class will be off. You see, you are very much agree to come here, okay, and talking to each other. And but your preparation in between, you will go for the preparation, okay, whatever you have. So you are going for the your exam preparations. So after coming here, you discussions. You have very little time to read actually. So before that, you will do everything for course exam preparation. So, okay, night only, and that time the all students are one in a room. So you are enjoying also. So very little time for exam. Okay, but it's okay. It's fun exam. Don't worry. We'll manage, I think. I think you will manage and we will also manage. But the whatever the material, before you come here, you will collect. And each because you have that time practical will going on whole day, you have not time. First half maybe physics chemistry, second half maybe electronics, and no time for you, and you have adjusting with the circumstances, the fooding lodging etc. And water, drinking water is a problem, so always there. So all these are going on, but night you can stay and read. So everything will be in your hand, okay, for the course material. So after that you will go. So maybe you will have time. The shifting, everything will fit. Maybe 15 days will fit everything. So you accommodate and you give exam.
Ma'am, is the class start from 9 p.m. or 10 p.m. on offline class?
Actually 9. Routines are same.
It's 9 p.m.
No PM. No AM. 9 AM to actually this maybe 6 PM. And lunch.
And then when the class will finish?
That depends. You have practical, so Viva, etc. Because you are coming for practicals, Viva, and some views. So depending on how it is different from different. different department can take different time. So according to central routing will be split again.
Ma'am, in the practical, do we have to write the reactions also?
This one by one. Practical fiber will be one by one, or we can ask two at a time and write down something. Yes, that time is easy for us to ask something, draw the structure and etc. I will discuss you, give you everything about the case. This before you will come. I will first your practical will finish the training from the inorganic and physical. Then we will discuss, and I will
Ma'am,
give.
I was asking about the assignment. In the experiment section, do we have to write the reactions?
Right, that is not a problem. Your submission is must, and what the topic is must. If you make it, because actually your submission is must, you can go in your choice. That is, there is no failure.
Okay, ma'am.
If you want to put the chemical reactions, you are welcome. Because sometimes it's good because now we are asking this question in Bible. So if in your assignment, so you can open this assignment and you can see the PDF, whatever you make. So that will helpful as a course material for you.
Okay, ma'am.
Okay. So you have to set up with a new situation. Okay, it's not a big problem. Maybe maybe some few are not adjustable, but most of the students are when come together and they are all students. They very quickly make friendship and there is no problem. I see now that last final semester PG. They came here and now they are very happy. No problem. They are all the time working, going, etc. They are happy and they
Ma'am,
are
is there any chance of syllabus reduction?
syllabus is whatever we go through up to this much is your syllabus. We can't every year not possible to cover the whole syllabus. That year, this year we are unable to go still the stereochemistry because stereochemistry is very difficult to understand through this online mode because there is some no more something.
No,
Don't
ma'am,
you
like for
okay?
offline exam, is there any syllabus reduction? Will there any chance?
Automatically reduced actually because of the exam simplicity. I give you so much like for NMR there is no complication. You see my slides are enough to understand. I will go give you the all type of moieties which will come for the exam to understand for your exam. So it makes already reduced and very simple. And but you collect all the course material, whatever you write down or etc. So that after actually for exam purpose you have not so much time to make you prepare collecting this thing. Okay, so before that you will collect it. But at night, each night you just go through each paper and then you will be benefited. Within 15 days you can make it possible because that time only practical classes will going on, not the theory classes. Hopefully theory will be finished. Hopefully not. It's my department I know. Rest I don't. Okay. You are
Ma'am,
yeah, the hostels, the how is there?
ma'am, when will you report the campus
Hmm?
for hostel? Ma'am, আমাদের কখন ক্যাম্পাস রিপোর্ট করতে হবে?
I think Data is not here because he is out of station for some reasons to Delhi. So after he will come, then it will depending on the actually the evacuations from the higher semester shifting to the new. Then your hostels is they can provide.
Ma'am, is there any chance for exam postpone?
Postponement maximum 15 days. There is a chance, maximum.
And then in next semester we'll get less time if the exam postpones.
No, because you are already late, no, one semester. Because even you have no summer vacation. You know.
Yes.
Otherwise, you lose your year.
Ma'am, if in the offline there will be no summer vacation.
Yes, you have now your academic calendar. There is 15 days gap just between two semesters.
And ma'am, about the puja vacation.
There is no puja vacation. What is puja vacation? Only one day is puja vacation. Dasami and I think Navami and Dasami. There is no as such puja vacation. In few days you are getting leave. But summer vacation is lot, na? Like 2.5 months. That is now reduced to 15 days. But for your case, it's like if it's shifted to 15 days, so you lose 15 days, so 1 month again you lose actually. So mid semester you will get again very less time because you have to reduce your time frame. Otherwise, you can't accommodate within 4 years. Okay, you have to finish your course now within 4 years. So like everybody will pass out with from different institute 2 months before you. They are going for placement and you will be late. That is not desired na, for you. You need to at par with the other institute within the time frame. So that's why you have to sacrifice the leaves and etc. That's not your choice, that's our choice. Your syllabus, your full course will be within the stipulated 4 years course, not the 4.5 years. Whatever we have to back to the previous mode, whatever the virus is coming, they are not hamper like this, disrupt this system. Okay. So for this one, we'll be relaxed with the exam. We will enjoy. Don't worry so much. Just thinking that you are coming, mentally prepare, coursework you are collect carefully so that you will be not vexed before the exam night. Okay, that is your actual time to read. I know. And actually sitting together, the students, you will manage your exam. That is not a problem. Okay, so bye now. Okay, next week maybe I'll not able to take class at this time. Next week, what is the date? I think it's 10th, na?
Yes, ma'am.
Oh, actually I am involved in this convocation 11, so I have lots of work in 10. So you can give me one day. No, actually next week I have lots of work. I have no time. So next after that I will take another extra class. Okay,
Okay, ma'am.
I will manage.
Okay, ma'am.
Okay, so because maybe practical will finish. Hmm? What about the practical? Physical is done.
Started, ma'am, physical.
Okay, we will manage one day, whatever the time, or at the evening maybe we can manage one day with this practical. Okay, after all classes, because still now we are in online mode up to 21st or 28th, so we can manage these classes. Okay, so next week maybe it's not possible, so I will not take next week class. If any sir will wish, I think me and Professor Nondi will not able to do. If Professor Chattopadhyay can take my class, I talk to him. Okay, so I can take his class on Monday. I will talk to him. So after that, let you know. Okay, bye. Now I am leaving. Okay.
Thank you, ma'am.
Ma'am.
Thank you, ma'am.
Thank you, ma'am.